Good day, everyone. In this video, I'm going to discuss one binomial distribution question in which the n value is unknown. N value is not given in the question, and we have to find the n value. Okay, so let me read out the question for you. In a toss of a fair dice, obtaining a number which is a multiple of 3 is considered a success. Find the number of tosses required so that the probability of obtaining at least one success is greater than 0.9. So when we do a binomial distribution question, there are three important information will be needed, which are basically N, P, and Q. N is the number of trials, in this case the number of tosses, P is the probability of success, and Q is the probability of failure. So if we know our P value, we can automatically compute our Q value by doing 1 minus P. Okay, so basically in this question n is not given and we have to find out the value of n. So that is our task. When it comes to p and q, there are some information given. So this question involves a fair dice. Inside a fair dice we'll have number 1, 2, 3, 4, 5 and 6. There will be 6 numbers in a dice and these are the outcomes. According to the question, obtaining number 3 and number 6 is considered success. So in that case, probability of success I can put as 2 over 6, which I can simplify as 1 over 3. So my probability of success will be 1 over 3 and automatically my probability of failure will be 2 over 3. So these are the information you must extract from the question. So as we continue, we're gonna focus on this particular statement. Probability of obtaining at least one success is greater than 0.9. So when they say probability of obtaining at least one success, that means they are referring to probability of x being greater or equivalent to 1. And they want this probability to be more than 0.9. So this is what the statement is trying to convey. From here, in order to continue, we cannot further expand this one. Since we don't know our n value and we are starting with the value of 1, we don't know where to stop. Let's say the n value is equivalent to 4. So in that case, I can write probability x greater than equals to 1 as probability x equivalent to 1 plus probability x equivalent to 2 plus probability x equivalent to 3 and plus probability x equivalent to 4. And I can stop right here because I know the n value and I know where to stop. But unfortunately, in this question, the n value is not given and that is what we are trying to find out. So when we face this kind of scenario, we have to do the supplementary method. So what is meant by supplementary method? Because it is said that probability x must be greater than 1, we can also say that probability of x being greater than 1 is also equivalent to 1 minus p x equivalent to 0. This will be a better approach to settle this question. So in when we continue, we're going to write probability x equals 0. We have to put 1 minus in front greater than 0.9. So I literally replace this one with this information. That's all. As simple as that. Okay. Let me continue at the bottom here. So we're going to first find out probability x equivalent to 0. So we're going to put NC0, probability of success, which is 1 over 3 to power of 0, and then 2 over 3 to power of n. So which we can simplify as 2 over 3 power of n. Because any number choose 0 is equivalent to 1 and any number power of 0 is actually equivalent to 1. So end of the day, only this particular term is remaining. So I can continue from here. 1 minus probability x equals to 0. I already changed into 2 over 3 power of n is greater than 0.9. So as I continue, negative 2 over 3 to the power of n is greater than negative 0.1 because I'm going to shift this 1 the other side. So I'm going to get negative 0.1 and then 2 over 3 power of n is smaller than positive 0.1. Why does this happen is because this negative I'm bringing it down, so it's going to become a positive number, and remember to change the symbol, otherwise there will be a mistake in the final answer. So from here onwards, what am I going to do? I'm going to add log in order to find the final value. So I'm going to add log base 10 and I'm going to add log base 10. So after I add log base 10, this n I can always pull in front. So it's going to be n log base 10 2 over 3 is smaller than log base 10 0.1. So let me continue here on the right hand side. As I continue, my n will be greater than log base 10 0.1 divided by log base 10 2 over 3. So you might notice I have changed back the inequality again. What is the reason behind this is that this particular value holds a negative value. If you press calculator, log of fraction 2 over 3, you'll get a negative answer. So when you divide or multiply by a negative value, your inequality symbol must be changed. So end of the day, you'll end up getting n is greater than 5.679 in your calculator. So the next whole number will be 6. So that should be the final answer for this question. So the minimum number of tosses that he need to make in order to make sure that his probability of success is greater than 0.9 will be 6 number of tosses. So please revisit the entire video. I hope you guys understand. If you have any question, you may comment on the comment section. I will provide my further explanation. Thank you.